Okay, so quasi-concavity and quasi-convexity. So what we have done in convexity and concavity and convexity is related to functions of single variable. Okay, so one thing is concave or convex for some single variable function f of x. So that is very straightforward. We just look at f double prime of x. Okay, so if f double prime of x is positive, okay, then what it looks like is that the slope is increasing. F double prime is slope of the slope. So slope should be increasing. So it looks something like this. Okay, so this function is what we call as convex. On the other hand, when it is negative, it looks like this. Okay, and this is concave. Right. Next is quasi-concavity and quasi-convexity. So this concept is particularly important for economists, and we saw that in case of the convex preferences. So we made this statement in the very first lecture of consumer theory that if preferences are convex, then this implies that my utility function is quasi-concave. So at that time, I gave one definition of quasi-concavity, which was that, okay, the definition of the quasi-concavity which we looked at that point of time was that if there are two bundles, x1 and x2, okay, these are vectors, x1 vector and x2 vector, such that utility at x1 vector is equals to utility at x2 vector, then for all t belonging to 0, say 1, let a bundle y will be equal to t times x1 vector plus 1 minus t times of x2 vector. So utility at y vector will be greater than utility at x1 vector and utility at x2 vector. Okay. So basically, let's look at this step by step. So first, you take two bundles x1 and x2 such that the utility is same at these two bundles. So suppose this is my bundle x1 vector and this is my bundle x2 vector. So utility same ka matlab hai IC passes through these points. So this is some IC passing through these points. Okay, then the next step is for all t belonging to 0 to 1, take a bundle y, which is basically a convex combination of x1 vector and x2 vector. So what this implies is कि एक convex combination ले लो इन दोनों bundles का, which could be anywhere on the line segment connecting these 2 points. ठीक है, so ऐसा कोई point ले लो and call this as my y vector. So now the final step is that utility at y vector is greater than utility at either of these bundles. Okay, so this was the working definition of quasi-concavity that we looked at. Now we are going to look at the actual mathematical definition, properties, theorems, वो सब चीजें हम देखेंगे. Okay, so quasi-concavity. So think of mountain in Swiss Alps, cows grazing and वो सब चीजें. ठीक है. Now forget about cows and snow and ask whether the function defining the surface of the mountain is concave. ठीक है, एक surface का concave होने का मतलब क्या है? A surface being concave means this is a concave surface. If I connect any 2 points x1 and x2 on the surface, the connecting line segment always lies above the surface, right? So this is a concave surface. So now what you imagine is a mountain like this. Is this surface concave? Now, if you connect these 2 points, then the line segment lies above. But if I connect these 2 points, then the line segment lies below. So this particular surface is not concave. Okay. So this mountain would be concave if every straight line connecting 2 points on the surface lies everywhere on or under the surface. Okay. So this is not happening right now. Oh, sorry, concave की बात हो रही थी. Wait, this I drew a convex surface. Sorry, my bad. This is a concave surface, right? So if you connect a line segment, it lies below the surface. Okay. Now this particular surface is not concave and it is not convex either. Because for some combination, I see line segment lying below. For some combination, I see line segment lying above. So this is neither concave nor convex. Okay. So one thing is clear that this mountain that I have in mind is neither concave nor convex. So now suppose the now this mountain is basically called a pinched cone. Okay, this is known as something we call as a pinched cone. अब ये pinched cone structure जो होता है, it is something in common with some other type of structure, which is like a dome. So imagine a dome. Okay, so one is this pinched cone, which is like a mountain, like this, and other is a dome, which looks like this. Dome would look like this. So this is my pinched cone. This is my dome. Now there is one common thing between a pinched cone and a dome. So suppose I point out all the points at a given particular height. Okay, so अगर मैं height map करूँ, suppose this is height axis. So अगर मैं height equals to this अगर mark करूँ, ठीक है? So corresponding points in the pinched cone will be a circle, right? अगर ये mountain बहुत ही smooth इस type का है, then all the points on the mountain surface which are at a particular altitude will basically form a circle. A similar thing will happen for a dome. Dome के लिए भी ये एक circle ही होगा ये. So suppose this height is, let's say height 100 meters or whatever. Okay, then I do it for 200. Okay, so for 200, I will get this structure. यहाँ पे I will get this structure. Okay. And similarly for okay, so what I'm doing is I'm basically mapping the points on the surface of the earth at which the altitude of the mountain is greater than or equal to this red altitude. This is, let's say, 200 meters. So all these points correspond to altitudes in the mountain which are greater than or equal to 200 meters. So let me just restart the webcam. This is lagging a bit. So hope this doesn't lag now. Okay, so all the points above some particular altitude are going to form a circle. So all these points on the surface of the earth under this dome will have altitude greater than 200. Okay. So there is one connection between these two structures, the pinched cone and the dome, that when I take these sets about of points on the surface of the earth where the altitude is greater than equals to any specified level, it always comes out as circles. So I can take a third altitude here. ठीक है, ये 300 meters का altitude ले लो. ठीक है, if you take 300 meters altitude, okay, then again you will see pinched cone structure. Sorry, this circular structure. Right, यहाँ भी एक circle मिलेगा तुमको. So you see that all these sets of points are going to be circles. अब ये sets में कैसे define करता हूँ? So these sets they get defined like this. All the points x, y such that altitude of the mountain at x, y is greater than or equal to some a value. Okay. So all such sets for all a belonging to R are circles. Okay. Now I'm not interested in them being circles. What I'm actually interested in is them being convex sets. Now circle is a convex set. Can you tell me what is a convex set? Can you define a convex set? Can anybody tell me the definition of a convex set? Who all are online? Okay, so just two of you, Somijyoti and Vinay. Can anybody tell me what is the definition of a convex set? Come on, convex set definition, very bread and butter kind of thing. So a set is convex if for all x, y belonging to the set, lambda x plus 1 minus lambda y also belongs to the set. Okay, so basically we are saying that a circle is a convex set. Why? Because if you have any 2 points in the circle, the connecting line segment always lies in the circle. So this is a convex set. A triangle looking like this is always a convex set. कोई भी 2 point ले लो triangle में, line segment always lies in it. Quadrilateral like this, convex set, all line segments lie in the set. But if you take a quadrilateral like this, then it is not convex. Because I can take this point and connect them, then this section of the line segment lies outside. Right. So this is not a convex set. So what I am saying is all the sets which are defined like these, which are known as the upper level sets. Okay. Upper level sets, they are all convex. Okay. So the set of points at which the height of the mountain exceeds any given number is convex. Okay, so that is the definition. In fact, each contour line of this mountain, like each contour line of a perfect dome or a cone, is a circle. But circle hona compulsory nahi hai. You can even have them as triangles or squares, as long as each upper level set is convex. This particular structure will be considered as quasi-concave. Okay, so let's come back to the definition of Cobb-Douglas utility function and see why that is quasi-concave. So utility x, y is equals to under root xy. So in this case, my ICs, they used to look like this. Okay, this was for utility level, let's say 10. This was utility level 20. This was, let's say, utility level 30, and so on. So कोई भी upper level set देखो, So for level 10, the upper level set looks like this, which is obviously convex. Okay, for level 20, the upper level sets looks like above this curve, so that is also going to be convex. For level 30, it looks like this, so this is also convex. Okay, so कोई भी upper level set में लूं, let's say utility 10 का, so then the upper level set looks like this, and this upper level set is convex for the simple fact that if I take any 2 points in this set and connect it, the line segment lies completely inside this set, which is this purple region. Okay, so for the Cobb-Douglas utility case, you can claim that all upper level sets are convex, which implies that the utility function is quasi-concave. Okay. Okay. So here we are going to look at some definitions. First, if you the contours are they are called level curves. So what is level curve and level set? So level curve is basically all points x comma y such that f at x comma y is equal to a. Okay, and upper level sets, they are all points x comma y such that f of x comma y is greater than or equal to a. Okay, and then we have lower level sets. Lower level sets, these are all points x comma y such that f of x comma y are less than or equal to a. Okay, so level curves, so if I draw a pinched cone which looks like this, so for any height level h or a, any height level a, what is going to be the upper level curve? So upper level curve will be the points at which exactly a value happens. So this is my upper level curve. This circle is my upper level curve. This thing is my upper level set, and the lower level set is everything where value is lower. So value lower kahan pe? Value is lower for these values. Yahan pe altitude is lower. Okay, so that is going to correspond to all these values. Everything outside the upper level set is lower level set. So this is my lower level set. Is this clear? Level curve, upper level set and lower level set. So upper level sets वो points है जहाँ पे function की value किसी एक level से ऊपर है. Lower level sets are those values at which those inputs at which function's value is lower than the set threshold, and level curve is basically those values at which exactly उतना है. ठीक है. So एक clear life अगर मैं example दूं, so suppose I talk about some height function. Okay, so I say height of a person equals to 6 feet. इसके मुझे upper level set, lower level set and level curve निकालना है. So level curve will be points which will be basically people with height exactly equal to 6 feet. Upper level set will be people with height greater than or equal to 6, and lower level set will be people with height less than equals to 6. Okay. Now let's take a real life example. Sorry, not real life, but mathematical example for a single dimensional function. Suppose f of x is equals to x square. एक single dimensional function है. Find level curve, upper level set and lower level set for a equals to 4. ठीक है, so a equals to 4 के लिए मुझे ये सारी चीजें निकालनी है. So लेवल कर्व क्या होगा? All points x, क्योंकि यहाँ पे इनपुट इज जस्ट x. So सिर्फ सिंगल इनपुट का फंक्शन की मैं बात कर रहा हूँ. So all points x such that f of x is exactly equal to 4. So ये सेट में कौन से पॉइंट्स होंगे? f of x equal to 4 में which points will satisfy f of x equal to 4?
2.
Just 2.
Plus or minus 2.
2 and minus 2. What will be the upper level set? अच्छा, लोअर लेवल सेट बता दो पहले. लोअर लेवल सेट क्या होगा? f of x less than equal to 4.
-2 to 2.
-2 to 2. एक्चुअली इसको मेरे को -2 and 2 ऐसे लिखना चाहिए. ठीक है, हाँ, -2 से 2. And upper level set will basically be all x such that f of x is greater than equal to 4. So that will be equal to -infinity to -2 union 2 से infinity. Okay, so if I draw the graph of this particular function, so I'm doing this without the help of graph because math is important right now. Graphically तो कर ही लोगे. This is x square. ठीक है, तो मैंने लेवल सेट किया है मेरा 4 पे. So it is here 4. So this point is 2, this point is -2. So this is my lower level set. This is my lower level set and this is my upper level set. Okay. Now so कई बार मेरे level sets जो होते हैं, they will not always look like smooth circles. Sometimes they can look like this. Okay, so you see this figure. So sometimes what happens is that my level curves, they will start looking like this. So it is possible that a mountain is uneven, right? A mountain can be uneven. So for this uneven mountain, when level curves looks like this, then this particular function is not quasi-concave. Okay, why? Because I can connect 2 points here and the line segment lies outside the set. So the level sets are not convex. So that is the reason why this particular function is not quasi-concave. Okay, so the definition of a quasi-concave function is basically that the upper level sets are. So definition of upper level set to मैंने बता दिया already. Sorry. Definition of upper level set is all points x in the set such that f of x is greater than equal to a. So with the help of example हमने देख भी लिया है कि कैसे define होता है. Now the definition of quasi-concave function is that all the upper level set is convex. All the upper level sets must be convex. Okay. Similarly, I can define lower level sets. So lower level sets is all points in the domain where f of x is less than equal to any given value a. So in case of a mountain, so a function is called quasi-convex if every lower level set is convex. Okay. So lower level set convex का मतलब है it is quasi-convex. Okay, and upper level set convex का मतलब है it is going to be quasi-concave. So this definition is important, the definition of quasi-concavity and quasi-convexity. These two definitions are important. So can you tell me if this function is quasi-concave or quasi-convex? Look at the sets I have drawn here. This is my lower level set and my upper level set is a union of these two. So इनमें से कौन सा set है जिसमें if I connect any 2 points, then the line segment will lie completely inside the set.
So lower level set.
Very good. So lower level set के अंदर if I take any 2 points like this and this, and I connect it with the line segment lies completely inside the set. But if I do the same for upper level set, I take this point, and I draw the line segment. So this section of the line segment is lying inside the lower level set, not in the upper level set. So the lower level set is convex, but this is not convex. Okay. So coming back, lower level set is convex. So is it quasi-concave or quasi-convex?
Quasiconvex.
Very good. Okay. So it's as simple as this. Okay. Lower level set, so you have to see lower level set मेरा convex है या upper level set convex है. Okay. So mostly जो example आएगा, it will be from a single variable function. It should be from a single variable function. अगर numerical आया तो, or it will be on one of the other types of theorems, या फिर under root xy. Cobb-Douglas का वो लोग पूछ सकते हैं. Cobb-Douglas is important. ठीक है. Let's look at a proposition. A concave function is quasi-concave. A convex function is quasi-convex. So मुझे ये पता है कि मेरा x square जो है, it is a convex function. And यहाँ मैंने देखा it is also quasi-convex. ठीक है. So basically what happens is that convexity is the most stricter thing to apply. Not all functions can be convex. Quasi-convexity is like partial convexity. So it's a slightly simpler thing to pass by any function. It is a less strict condition. Convexity and concavity are stricter. Quasi-concavity, quasi-convexity are lower. So if a function is convex, it will also be quasi-convex. So in the set of all functions, this is quasi-concave and this is quasi-convex. Okay. This is concave and this is convex. So all convex functions are quasi-convex. Okay. And all concave functions are quasi-concave. And more interestingly, there are some functions which are both quasi-concave and quasi-convex. Okay, so some functions can satisfy both the properties, and there are some functions which are neither. Okay, यहाँ पे मेरे पास बाहर में are functions which are neither quasi-concave nor quasi-convex. So as we progress, we'll do some examples about it. But herein we have this proof, a very important proof about how a concave function is quasi-concave. Okay, so this proof is very important for you. It can be asked in ISI subjective part. Prove that a concave function is also quasi-concave. So for that, you need to know the definitions. Okay, so definitions kya hai meri? Definition of so what we'll do is we assume concavity and show quasi-concavity. Okay, so assume concavity ke liye what we say, let x comma y belong to the domain of the set S. Then concavity implies f of lambda x plus, okay, 1 minus lambda x plus lambda y must be greater than or equal to 1 minus lambda f of x plus lambda f of y. So this is the definition of concavity. Where have we seen this definition in microeconomics? Can you tell me? We have looked at this mathematical definition of concavity in microeconomics in one place. याद आ रहा है कुछ? We said that a particular function looks like this. These are the values. This is the expected value. This is the expected x and so on.
Same properties of indifference curves.
No, not properties of indifference curves. This we did in case of insurance and uncertainty. So we said that utility from wealth function is concave. So therein I had given this definition of concavity. ठीक है? Convexity की definition में यहाँ पे less than equal to हो जाएगा. That is the only change. ठीक है? So it's nothing new for us. This concavity definition, utility from wealth curve was assumed to be concave when we did that particular topic. Okay. So concavity of f implies this thing holds. Okay. Now let us take that x belongs to some p of a set. matlab, so what we are going to do is x and y are my two input points. So let a be a real number and let x and y be points in the upper level sets of PA. So मुझे क्या show करना है? I need to show that upper level sets are convex. Right? This is what I have to show. This is what I am assuming. Concavity, I need to show that the upper level sets are convex. So implies for all x comma y which belong to some upper level set PA, okay, I need to show that lambda x plus 1 minus lambda y also belongs to PA. Okay, so this would imply that my upper level set is convex. Okay, so what I'm doing here is that I'm saying that there is some upper level set PA. So this is my upper level set. In that, I'm taking 2 points x and y. So I'm showing that for any x and y belonging to any PA, कोई भी PA ले लो upper level set, उसमें कोई भी x and y ले लो, इनको connecting line segment will always lie in PA. That is what I'll show if I show this particular thing. Okay. Okay, so I know that this thing holds because it is concave, and I need to show that this thing will also hold. So basically, I want to show that this would imply this. Okay. Now 1 minus lambda f of x plus lambda f of y. Okay, this is greater than equals to 1 minus lambda a plus lambda a. Why? Because f of x is greater than equal to a and f of y is also greater than equal to a. Right? So f of x is greater than equal to a and f of y is also greater than equal to a. Why? Because since x comma y belong to PA, तो PA में कोई भी अगर point रहेगा, उन पे functional value should be greater than equal to a. So this implies 1 minus lambda f of x plus lambda f of y must be greater than or equal to a. Now concavity definition क्या कहती है? That f of 1 minus lambda x plus lambda y should be greater than or equals to this thing. So this you can call equation number inequality 1. Inequality 2 could be f of 1 minus lambda x plus lambda y should be greater than or equal to 1 minus lambda f of x plus lambda f of y. So you can call this as inequality. So using 1 and 2, I can claim this is greater than this and this is greater than this. You see, this is the common link here. So 1 comma 2, it implies f of 1 minus lambda x plus lambda y must also be greater than or equal to it. So ये जो point है मेरा 1 minus lambda x plus lambda y, this is my point 1 minus lambda x plus lambda y. इस पे functional value is greater than equal to a. This implies 1 minus lambda x plus lambda y also belongs to PA. ठीक है? So this could be an interesting proof. आज तक पूछा नहीं है ISI ने, but this is in your syllabus. So I expect at some point they are going to give it. ठीक है? क्योंकि अब तक पूछा नहीं है, the probability of it being asked is pretty high. So इसलिए do attempt this for both concavity and convexity. Convexity के लिए पूरा greater than equal to होगा, less than equal to हो जाएगा. So proof remains similar. So to recap, what we did is we assumed that the function is concave, and then I took 2 points in upper level sets PA, and using these inequalities, your two-step inequalities, I showed that if the 2 points are in upper level set PA, then any intermediate point will also lie in the upper level set PA. So this automatically shows that my PA set is convex. So if the upper level set is convex, then obviously my function is quasiconcave. Okay. Now, the converse is very important. The converse of this result is not true. A quasi-concave function may not be concave. ये पूछा हुआ है ISI ने at some point. So they asked this to show that a quasi-concave function may not be concave. Okay, so our Cobb-Douglas thing, f of xy equals to xy, this is quasi-concave but not concave. Okay, so utility equals to xy. Utility equals to x into y. This is quasi-concave but not concave. Okay, so utility equals to xy lies somewhere here. This is my function utility equals to xy. Cobb-Douglas. It is quasi-concave but not concave. So how do I show this? First thing, it is obvious that it is quasi-concave as all upper level sets are convex. ठीक है, so all upper level sets are convex. इसको show करने के लिए की जरूरत नहीं है. ठीक है, you can draw some indifference curves and basically show it. So that part is not very complicated. Another way to show that it is quasi-convex can be reducing MRS. So MRS reduces as x increases. This implies function is quasi-concave. So this could be a valid line of thought, but इसकी जरूरत नहीं. ठीक है? Frankly, he's not interested in you proving that utility function xy is quasi-concave. He's interested in you showing that it is not concave. That is the crux of the question here. So how do I show that it is not quasi-concave? So दो point ले लो. What is concavity? Concavity says that if concavity says concavity के लिए हम क्या करेंगे? दो point ले लेंगे 0, 0 and 1, 1. So I know that functional value at 0, 0 is 0 and functional value at 1, 1 is 1. Right? Okay. So concavity definition क्या बोलती है? Concavity says that f at lambda x 1 minus lambda x1 vector plus lambda x2 vector must be greater than or equal to 1 minus lambda f of x1 vector plus lambda f of x2 vector. This is the definition of concavity. ठीक है, concavity की definition ये कहती है मुझे. So ये 0 0 और 1 1 को हमारा वेक्टर्स ले लेते हैं. x1 वेक्टर इज इक्वल टू 0 0 एंड x2 वेक्टर इज इक्वल टू 1 1. ठीक है, एंड माय लैम्बडा, ओ नो सॉरी, x2 वेक्टर को ले लो 2 2, सॉरी 2 2 which is equal to 4. x2 वेक्टर ले लो 2 2 एंड लैम्बडा ले लो हाफ. ठीक है, so now what does this left hand side become? Left hand side will become f of half 0 0 plus half 2 2, which is f of 1 1, which is 1 into 1, which is 1. And अब right hand side ले लो. So right hand side will be what? Half f of 1 1 plus half f of 2 2. So this is half into 0 plus half into 4. So that is equal to 2. Okay. So here left hand side is 1 and right hand side is 2. So clearly left hand side is less than right hand side. But I wanted to show left hand side greater than equals to right hand side. So this implies that the function is not concave. So this is sufficient to show at this point. All right, another interesting thing is this particular proposition. Now, iska proof nahi puchenge, but you need to remember the result. The result says that if a function is, let's say u is a function of many variables and g is a function of single variable. If u is quasi-concave and g is monotonically increasing. Okay, so let's say for example, ये सारे propositions important है. क्या पूछ लेगा इसमें से ना? We don't know. So this single document about quasi-concavity, quasi-convexity, it's very essential. So this is there in the multivariable math syllabus. बाकी के जो multivariable की चीजें हैं, they are not important. There are only two things we are going to focus on in multivariable for IIT JAM. That is going to be quasi-concavity, quasi-convexity, which we are doing today, and the other thing will be this thing, linear programming. ठीक है, so इन दो चीजों पे ही हम focus करेंगे because they have not asked the other things yet, so we need not delve there. But इन दोनों के दो सवाल पूछे. In the last paper, they have asked 2 questions for each of them. So मिला के ये syllabus से they have asked about 7 marks. So that's why it's important. Okay, so u is a function of many variables. So let's u equals to under root xy. Okay, and g is a single variable which is increasing. So g of z is equals to z plus 2. Okay, so what it says is that if this function is quasi-concave and this function is increasing, then g of u of x comma y is also quasi-concave. Okay, so what will be g of u of x comma y in this case? अगर ये मेरा u function है, ये मेरा g function है, what will be the composite function g of u of x comma y?
Root xy plus 2.
Very good, root xy plus 2. Root xy plus 2. So हम लोगों ने ये सब पढ़ा था ना फर्स्ट लेक्चर में कि दिस इज मोनोटोनिक ट्रांसफॉर्मेशन. ठीक है, यहां से यहां गया monotonic transformation. So we said at that point monotonic transformation कोई important property change नहीं करता, and quasi-concavity is a very important property. So quasi-concavity remains intact under monotonic transformation. ठीक है, So, so that's about monotonic transformation. So monotonic transformations will leave my quasi-concavity or quasi-convexity unchanged. So the same holds for quasi-convex functions also, by the way. Okay. So if you use a quasi-convex and g is decreasing, so pura ulta ho gaya for quasi-convex, then a function f of x, g of g of u of x is quasi-convex. Okay, so quasi ठीक है, ये एक error है इसमें. This should be convex. So ये quasi-convex होना चाहिए. Now the question is, why are economists interested in quasi-concavity? इसका एक one word answer है, quasi-concavity ensures that utility maximization problem has a unique solution. Okay, so quasi-concavity ensures that utility maximization problem has a unique solution. तो इसको भी ग्राफिकली समझते हैं, इसका कहने का मतलब क्या है. So let's say my utility function looks like this. So इस बजट लाइन के लिए utility maximization का unique solution. But if my utility function it looks like this, ये मेरा अगर इंडिफरेंस का है, so then utility maximization के दो solutions है, this and this can both be the solution to utility maximization problem. Right. Similarly, अगर मैं, okay, by the way, why is this not quasi-concave? Because if I connect these 2 points, then the line segment lies below. I want line segments to lie above. So that's why this is not quasi-concave. Anyway, coming back. अगर straight line भी है ना, if my ICs look like this, okay, if my budget line and IC, they are both coincidental, तो इस केस में यूटिलिटी मैक्सिमाइजेशन के लिए यू कैन पिक ऑल दी सॉल्यूशंस, ये सारे के सारे सॉल्यूशंस वैलिड है, यू कैन पिक एनी सॉल्यूशन. सो व्हेन क्वासी कॉन्केविटी इज नॉट इम्प्लाइड, then utility maximization can have multiple solutions, but with quasi concavity utility maximization will always have one unique solution. So that is why it is important. Now at your level वो uniqueness के क्या implications होते हैं, we are not interested in that. ठीक है, बट हमको कोई भी चीज पढ़ रहे हैं तो हमको पता होना चाहिए कि वो क्यों पढ़ रहे हैं. So this is something they can ask you in interview कि क्यों पढ़ रहे हैं quasi concavity. So you can give examples like this. Okay, by the way, this is what they asked to me in my ISI interview at that time when I appeared for PhD. Okay, functions of single variable की बात करते हैं. So functions of single variable में we already looked at x square and you rightly guessed that that particular function is quasi-convex. ठीक है, so और कुछ functions लेते हैं. Let's say f of x equals to x. So this function is option A, quasi-concave, option B, quasi-convex, option C, both, option D, neither. What's your answer? कोई एक पर्टिकुलर अपर लेवल सेट बनाओ, लोअर लेवल सेट बनाओ एंड चेक करो, बिकॉज आई टोल्ड यू इट इज पॉसिबल दैट इट कैन बी बोथ आल्सो. ठीक है, सो कोई भी एक लेवल सेट लो ए, उसका अपर लेवल सेट देखो, लोअर लेवल सेट देखो एंड देन टेल मी.
So neither.
Neither. Okay, so the correct answer is basically both. कोई भी upper level set ले लो A. So what will be the upper level set? A to infinity, right? So upper level set for ULS for any level A will be equal to A to infinity, which is convex. ठीक है, अब lower level set ले लो इसी का. Lower level set क्या होगा? All values where function is taking value less than A. So that will be this set. So lower level set for any value A will be equal to negative infinity to A. Now they are both convex. Okay, this is my upper level set, which you can see is convex, and this is my lower level set, which again you can see is convex. ठीक है, एक interval का convex मतलब it should be a joint interval. उसमें टुकड़े नहीं होने चाहिए. If it is a combined interval, एक contiguous territory है, then it is convex. So in this situation, what I see is both of them is convex. So this is also convex. This is also convex. So it is quasi-concave as well as quasi-convex. So the correct answer is. Okay. एक और example लेते हैं. Again, same options. The function looks like this. एक cubic है इस type का. Now what is the answer? Remember, कोई एक upper level set convex या concave नहीं होना चाहिए. All the upper level sets need to be convex for quasi-concavity, and all the lower level sets need to be convex for quasi-convexity. Okay.
Neither here.
एक convex. Sorry, can you repeat?
Neither in this case.
Very good. Neither, because you can construct one upper level set here, which looks like this. Let me change the color. So for this particular A, the upper level set will look like this. Okay, and the lower level set will look like this. So neither the upper level set nor the lower level set is convex. So the answer is neither in this case. Okay. So let's come to this proposition. A function of single variable defined on interval I is quasi-concave if and only if there exists a number x star such that f is non-decreasing on x less than equals to x star and non-increasing on x greater than equals to x star. So what this is saying is, on the real axis, there should be a number x star such that for all x less than x star, the function should be non-decreasing. So यहाँ पे the function needs to be non-decreasing, and यहाँ पे the function should be non-increasing. ठीक है, non-decreasing मतलब it should either increase or remain constant. So इस type का होना चाहिए till x star, and after that it can look like this. Okay, so something like this will be quasi-concave. Why? You can construct any upper level sets. कोई भी upper level sets बना लो. Always convex. Okay. Similarly, a converse definition is for x star, left में it should be non-increasing, right में it should be non-decreasing. So something like x square for x star equals to 0. So this was quasi-convex. Right? क्योंकि कोई भी मैं lower level set अगर बनाऊं इसका, lower level set is values where function takes values less than your a. So lower level set is now convex. So that's why this becomes quasi-convex. So one automatic corollary from this is all monotonic functions are both quasi-concave and quasi-convex. Okay, a function that is always non-increasing or always non-decreasing is automatically quasi-concave as well as quasi-convex, like f of x equals to x, f equals to x, y equals to x. Okay, so ये example हमने देखा था, this is both quasi-concave and quasi-convex. So a uniformly increasing function is both quasi-concave and quasi-convex. So with these results in mind, again, f of x equal to x cube is वही सारे options, quasi-concave, quasi-convex, both, neither. What is the answer? F of x equals to x cube.
Both.
Very good, both, because it is monotonic. Okay, x cube is a monotonic function. X cube का graph याद करो. X cube का graph looks like this. It is a monotonic function, always increasing. So it is monotonic, which implies it is both. So यहाँ पे कुछ बहुत sophisticated आता नहीं है quasi-concavity, quasi-convexity में. इस syllabus से ही सब कुछ पूछते हैं वो लोग. So that's why, and I've never seen a question outside whatever we have done. Now there's another characterization of quasi-concave functions. Now this characterization is something जो कभी पूछा नहीं. So this is something maybe they ask in the future. So a function is quasi-concave if for all x and x prime such that f of x is greater than equal to x prime. ठीक है, तो मैं 2 पॉइंट लूंगा x and x prime such that x पे functional value ज्यादा है. So again come to my pinched cone structure. So let's say this is my x prime and this is my x. So clearly f of x, which is altitude, is greater than f of x prime. So we have function of any convex combination. So इन दोनों points के बीच में कोई भी point ले लो y. So y पे functional value should be greater than or equal to f of x prime. ठीक है. So this says कि कोई भी 2 point लो x and x prime. So intermediate points पे function की value will be greater than the minima of these 2 points. So another way to characterize this is for all y equals to lambda x plus 1 minus lambda x prime, f of y should be greater than or equal to minima of f of x comma f of x prime. ठीक है. अब इसका proof तो I don't expect they'll ask, but this interpretation is important, and I've given you the proof. So the proof is something you have to work on. So if you want, I can tell you कैसे work करता है यहाँ पे. So again, proof में हम क्या करेंगे? We'll take x and x prime, and we'll assume. So take x and x prime. So proof लिख देते हैं इसका proof. Let x prime be greater than, no, sorry, f of x be greater than f of x prime. Then let y equals to lambda x prime plus 1 minus lambda x ऐसा ले लो. ठीक है. So suppose x and x prime, they both belong to some level set PA, upper level set PA. This implies f of x comma f of x prime. So f of x should be greater than equal to f of x prime, which should be greater than or equal to value a. Okay. Now, all I need to show, what I need to show is the point y belongs to PA, which implies okay. Okay, so I have to show that the point y also belongs to the upper level set. So how do I go about it? Now suppose that for all x and x prime, f of x greater than this thing, we have f of 1 minus lambda x plus lambda x prime is greater than equals to f of x prime. So this property is satisfied basically. What it's saying is this property is satisfied. So if this property is satisfied, this implies that f of y should be greater than or equal to min of f of x comma f of x prime. Now both these numbers are greater than equal to a. So this implies f of y is also greater than or equal to a, which implies y also belongs to p of a. So बहुत simple two line के proofs है सारे. Now I don't expect कि वो पूछेंगे ये proof क्योंकि उन्होंने वो वाला proof भी अभी नहीं पूछा है. Concavity implies quasiconcavity. If they ask that proof at some point of time, then maybe next time they ask this proof. Because they have not even touched that proof yet, I don't expect them to touch this one. But in any case, doing this will help you know कि proof किस तरह से form होते हैं. So that will build your confidence about proofs. So ये जो proofs मैंने किए हैं, do them again for quasiconvexity. ठीक है? That will build your proof making appetite. इसके आगे डिफरेंशिएबल फंक्शंस हैं, ट्वाइस डिफरेंशिएबल फंक्शंस, ये सारी चीजें हैं. ये सब हम नहीं करेंगे, ये सब हमारे लिए रिक्वायर्ड नहीं है. Because the exam is not asking bordered Hessian and all those things yet. So I don't see the importance of doing that. I think this much is sufficient. So technically speaking, तो ये सारी चीजें हैं syllabus में, if I talk about it frankly. But there's no point burdening your brain with all those things which have a very low probability of being asked. Okay, let us focus on things which have a high chance of being asked, so that we can focus. Okay, exam में 100% नहीं लाना है. We just need to clear the cutoff. Okay, so maybe if it happens कि ऐसा कोई question पूछ लिया, rest assured 99% students नहीं करेंगे उसको. So don't worry about such fringe questions. तो एक आधा fringe question आएगा exam में. It always happens. Let's not worry about it. But if you want to go about it, then I've given it here in the notes. So if you're interested कि bordered Hessian से quasiconcavity and quasiconvexity कैसे निकालते हैं, then you can go through it. But I'll be doing this for ISI. Okay, ISI के लिए I'll be doing Hessian and bordered Hessian when we start maths for ISI after JAM. JAM के लिए, frankly, I don't see the relevance right now. ठीक है, strict quasiconcavity. So यहाँ पे greater than equal to की जगह हर जगह greater than आ जाता है, तो strict हो जाता है. That definition. So as long as it is equality, inequality, weak inequality, it is quasiconcavity. When it becomes strict inequality, it becomes strict quasiconcavity. Okay. So the difference is, I see like this is weak quasiconcave, but not strict quasiconcave. Okay, so मेरा जो perfect substitutes है, they are weak quasiconcave, but they are not strict quasiconcave. Now, generally, when the word quasiconcavity is used, the examiner implies strict quasiconcavity, but in the proofs you can use greater than equal to. In the proofs greater than equal to use करके करो या simply greater than लेके करो, कोई फर्क नहीं पड़ता है. But ये नहीं है कि एक बार greater than equal to लिया और नीचे greater than करके कर दिया. Whatever you do, maintain uniformity. Don't get too confused about strict and weak, क्योंकि उसके ऊपर कोई इतना ज़्यादा game नहीं है. All right. So just to sum up, the important points here is level curves, upper level set and lower level set. ये तीन चीजें हमको पता होनी चाहिए. Knowing what is convex will define my quasiconcavity, quasiconvexity. Second thing is concave convexity implies quasiconvexity and concavity implies quasiconcavity. Okay. Third thing is that my monotonic functions. Oh, okay. All the U-shaped functions, these are going to be quasi-convex, and all the inverted U-shaped functions, they are going to be, मतलब ऐसे नहीं ऐसे भी हो सकता है, but as long as they are increasing first and decreasing next, they are going to be quasi-concave. And finally, monotonic functions are both quasi-concave and quasi-convex. Okay, so these are the things to keep in mind, and you need to keep in mind the proofs. Okay, so that wraps up quasi-concavity, quasi-convexity. In tomorrow's lecture, we will be doing linear algebra, linear programming. So linear programming lecture थोड़ा लंबा हो सकता है, because see right now linear programming जो है ना अपने आप में बहुत बड़ा टॉपिक है, and we are not sure at this point of time ki what is the scope at which JAM can go. So we will strictly restrict ourselves to the things which they have asked till now. ठीक है, वैसे देखा जाए तो लीनियर प्रोग्रामिंग की टेक्स्ट बुक से 600 पेज की लीनियर प्रोग्रामिंग की अपने आप में टेक्स्ट बुक्स होती है. So in tomorrow's lecture, we'll strictly do graphical method of doing it, of solving linear programming and the dual problem. We'll stick to that. उससे ज़्यादा हम करेंगे नहीं. Okay. But in future, so I don't expect them to ask much from linear programming क्योंकि बहुत complicated questions exam में solve नहीं कर पाओगे. So easy चीज ही पूछेगा examiner because it's an objective exam. They don't give you a lot of time to solve complicated problems anyway. Okay. All right, fine. So we'll look at linear programming tomorrow. So let's wrap up today's lecture now. Okay. All right, fine. So I'll see you guys tomorrow. Bye.
Thank you, sir.
Welcome, guys.
Thank you, sir.
Welcome.